Weight is one of the forces on our list, so let me tell you where that comes from. Suppose you have a ball like this, and the ball is, of course, made out of some sort of material like rubber or cloth or fabric or something like that, and the ball has a mass m. Now, you can think of mass as the sum total of all the elements, the constituents that the ball is made out of, like atoms or molecules, and if you add them all together, you get this property called mass. So the mass symbol m, and we'll give it the name mass. Now, what happens with weight, then, is what happens when you bring a mass like this, and you're something very big, say like a planet. The reason why weight would be important is because in the everyday problems that we work in a course like this, typically they are sort of performed on or near the Earth, and so all the cars and the balls and the airplanes that we deal with are sort of operating or moving near a planet, and so weight might have something to do with it. Where does weight come from? Well, it turns out that planets are extremely massive. They have a big mass too. All the rocks and the mountains and the lakes and the core that, say, a planet Earth is made out of all contributes to a huge capital M that it has. And whenever something has a big M like this, it turns out that all around that object, it creates a gravitational field all in the space around the object here. So these purple lines here, you can sort of think of this as a G field if you want. A G field. So these lines you can think of as a gravitational field that's created just because this planet here has such a large mass. Now what happens then is when the small mass of the ball or the rocket or the airplane or the small thing that you're dealing with in your problem is near the planet, on or near the planet, it is immersed in the planet's gravitational field. So this mass here is sort of in these lines here, which are sort of saying is the planet's gravitational field. And whenever you have something like a mass plus a planet like that combination like that, that's where weight comes from. So mass plus a planet gives weight. In fact, the definition of weight couldn't be any easier. Weight is just equal to m times g. So you just take the mass of the object that it has and multiply it by g, and you'll get the weight of the object. Now, what is g? G is the strength of the gravitational field that we're talking about, strength of this g field. And for Earth, of course, you may know the number from another class or just sort of common knowledge here. That g for Earth is always going to be 9.8 meters per second squared. So whenever you have an object near the Earth, like a car or a ball or an airplane that's doing something near the Earth, it'll have a weight which is equal to its mass times its gravity. So that's how you get the magnitude of the weight. Now the direction of the weight is always going to be straight down like that. So whenever you have an object with a mass on it, you say, hey, has a weight acting on it because it's a mass near a planet, weight is equal to mg, and the magnitude of that weight will always be pulling straight down. So you can just label it w or label it mg. In either case, whatever object this has a downwards force pulling out towards the center of the planet with magnitude mg, and that's what weight is equal to. Lastly, let me just say one more thing, in that mass is not the same thing as weight. So there's these two items here, mass, let's say, versus weight. Now, sort of, I think I mentioned at the beginning of the video, mass here, it comes from the sum total of all the atoms. Say if you use the term sigma here for sum, say you summed up all of the mass of all the atoms that something's made out of. If it's a car, there's going to be a lot of iron and glass and silicon and things like that. And if it's a ball, it'll likely be made of some sort of hydrocarbon if it's plastic and so on. So whatever those constituents are, they all have masses because they're made out of protons and neutrons and electrons. And if you sum all those together, say in the ball or the airplane and the car, that's where an object's mass comes from. And it turns out mass is something that an object always has as long as it exists. The only way to change that mass would be to break the thing apart or tear a piece off or add more to it. But that's the mass something has. And no matter where you would take it, anywhere in the universe, it always has that mass. Well, how about weight? Well, as we mentioned in this video here, sort of summarizing the video, weight only comes from when you bring the mass, that collection of atoms and molecules, near a planet. That's where weight comes from. So in other words, it is possible to find some place in our universe where there's no planets around, just some empty, vast element of our universe, and you can bring the object there. It'll still have its mass because it's still made out of those atoms and things that make up the ball or the car, but it might not have a weight because it might not be in the gravitational field of a planet. So although mass is sort of more fundamental, I guess I'll say here, fundamental because it's sort of how the object is made, if you want to get a weight out of it, you always need to be able to multiply by a g, which is the gravitational field of a planet. So g could very well be 0 if there's no planet around, meaning the object would not have a weight, but it still will always have its mass.